Today's lesson is about finding the perimeter and area of rectangles and triangles. You have a formula sheet that has some equations on it that will help you do that, and then you also have your calculator to help do some of the math so that you can worry about learning how to write down the work and the steps correctly. Let's get started. Okay, before we begin, you need to know what perimeter is. So what is perimeter? Perimeter is just the distance around a two-dimensional shape. So if you want to find the perimeter of a two-dimensional shape, all you need to do is add up or find the sum of all of its sides. So in this shape here, we have a two-dimensional shape with four sides right here, quadrilateral. Luckily, someone decided to give us side measurements, so we have 18 centimeters, 12 centimeters. If you know what a rectangle is, the bottom side will also be 18 centimeters, and then the left side will be 12 centimeters. So you could just add those four up to get the perimeter. What we're going to do, though, is use the formula that you have on your formula sheet. So I want you to get used to doing that, right? So on your formula sheet, the formula that's shown is P equals 2L plus 2W. So when you show your work, that's the first thing you have to write down, the 2L plus 2W. The reason it says 2L plus 2W is because rectangles have a length and a width, and a rectangle has two lengths of the same measurement and two widths of the same measurement. So here, I'm going to use L as 12, and when I think of width, I think wide, so I'm going to use 18 as the width, and I'm going to use those numbers and substitute them in for L and W. All right? So use this Math 6 formula to do that. I'm going to put 12 in for L, 18 in for W, and so that's the next line of work that I have to write down. And then I'm going to do my math. So 2 times 12 is 24, 2 times 18 is 36, which makes the perimeter of this shape 60 centimeters. All right, so notice with perimeter, whatever the label is on the picture, that's the same label you have to write in your answer. So if it's centimeters here, it's centimeters in the answer. Okay? So, to find the perimeter of any other polygon, find the sum of all of its sides. You don't have formulas on your formula sheet for all the polygons, you just have rectangles. So, if I give you a pentagon like this one, and I give you side measurements, you can just add all those measurements together to get an answer. So your first line of work would look like this. P equals with all of the numbers added together. And the second line of work is just the answer. P equals 68 centimeters. I'm sorry, 68 inches. Okay? So again, the label here, inches, is the same as it is here, inches and inches. All right? So take a second, hit pause, try to find the perimeter of each of these shapes, and then when you're done, unpause and we'll talk about it for a second. All right, so here are the answers. For the rectangle, I have a formula, so I wrote it down. P equals 2L plus 2W. L is 6 and W is 11. So that makes it 2 times 6 plus 2 times 11. So remember when you don't see a sign between two numbers and there's a parenthesis there, or when you see a variable or a coefficient together like this, that means to multiply. So 2 times 6 plus 2 times 11, that's 12 plus 22, which is 34. Inches is the label in the picture, so inches is the label in the answer. For the triangle, what you'll notice is there are four measurements there. The triangle has 3 sides, so one of those measurements is not a side. The 5 yards is a line that goes through the triangle, but it's not a side measurement for that triangle. So the 3 sides are 8, 9, and 7. So when you add those together in any order that you want to, remember commutative property, you can change the order around if it helps to make it easier. 7 plus 8 plus 9 is 24. So your work should look like this. It should be P equals with the 3 side measurements, and then P equals with the answer and label. All right? So now let's get to area. What is area? Well, perimeter was the distance around a shape. Area is the space inside a two-dimensional shape. So we have a rectangle again. We have a formula on our formula sheet for the area of a rectangle. We're going to be doing triangles also. We have a formula on our formula sheet to help us with the area of a triangle. So let's start out with the area of a rectangle. The formula on your formula sheet says that the area is equal to the length times the width. So again, remember, there will be a times sign between the L and W. So you just take your length and width and you multiply them together. So, just for your help right there, length and width. So here we have our rectangle here. Its width is 4, its length is 3. So start by writing down the formula on your paper after you get your length and width figured out. So A equals LW, or L times W, and then substitute or put in your numbers. So A equals 3 times 4, because 3 is the length and 4 is the width. And then the answer is A equals 12. The area is 12. We need a label. The label is going to have feet in it, but you may also remember this from elementary school. When you label area problems, the label has an exponent of 2 with it. So the way you read that is either 12 square feet or 12 feet squared. My question for you is, why does the label have that exponent of 2? So I'm going to show you that now, because I want you to understand why that's there. So the reason that's there is because you can divide this orange rectangle into little squares, which I'm going to do right now. Okay? I have 4 squares going across the width because the width is 4 feet, and I have 3 squares going up along the length because the length is 3 feet. So if you look at each one of those individual squares, you could label that as 1 foot and 1 foot. And if I continued labeling, I would have 1 foot, 1 foot, 1 foot, and 1 foot for the width, so that'd be 4 feet. And I would have 1 foot, 1 foot, and 1 foot for the length, which would be 3 feet. So what that makes is a bunch of little squares that are each 1 square foot, because it's 1 foot for the width and 1 foot for the length. So since each one is 1 square foot, I can then count how many are in the entire rectangle, and that will tell me how many square feet is equal to the area. Okay, so it's pretty literal, square feet. Okay, they're little squares that are 1 foot by 1 foot. So if I count them all, there are 12 of them. So the area that we calculated earlier was A equals 12 square feet, or 12 feet squared. And the number of little square feet inside the picture is the same. So that's why you label area problems in square feet. You can do this same thing with any shape. It's easiest with rectangles because none of the little squares inside get cut off. Like if this was a triangle, some of the squares would be partial squares, and you would have to kind of connect them with other little parts to try to figure out exactly what the answer is, and that can be really tough to do. So this is just the idea, though. So area has an exponent of 2 because you can make little square feet or square units of whatever kind, inches, yards, with your polygons. All right? So there are 12 square feet inside the rectangle, so the area is written as 12 square feet or 12 feet squared. All right, so now we'll do parallelograms. Parallelograms we didn't learn specifically about when we did shapes earlier, but a parallelogram is a 4-sided shape, so a quadrilateral, and it has a formula for its area, and that is BH. Well, B and H stand for base and height. The base of a shape, think about a statue maybe, that might be a good way to picture a base. A base is always the bottom or like the foundation of the shape. And then the height is how tall it is. So this is what a parallelogram looks like. I have labels, like measurement labels here. So you can see that the base, the bottom is 16 millimeters. That would be the base. And then the height is going to be how tall it is. You don't measure height diagonally, so 10 is not the height. You measure height completely vertically, straight up and down. So the height for this one is going to be 8 millimeters. All right? So with this one, 8 is not a side. 8 is just the height of the shape. So when you use your formula then, you start by writing your formula down, and you put your numbers in. So B is equal to 16, and H is equal to 8. Okay? One other little note about the base and the height are always going to connect and make kind of like a right angle, like it would be right here. So that's a good way to figure out which one's the base. Okay? So let's multiply. 16 times 8 with your Desmos calculator if you want to is 128. Remember, it's an area, so we have to put a exponent of 2 or an exponent of 2 with our label. So the answer is going to be the area is equal to 128 millimeters squared or 128 square millimeters. Those are the 2 correct ways to say it. All right? So I don't think this formula is on your formula sheet. I want to show you this, though, because this is going to help explain something important about triangles in a little bit. All right? So now let's do triangle. Look on your formula sheet. The area for a triangle is 1/2 base times height. So it's similar to a parallelogram, but we have a 1/2 in here. And that's why I showed you the parallelogram, because I want you to understand why 1/2 is part of the triangle formula. All right? B is still base. H is still height. So height is not always the side of the triangle. So we talked about that with parallelograms. It's how tall the triangle is or how tall the shape is. So I'm going to show you some examples of what height can look like. Height can actually be a side. So this is a right triangle because it makes a right angle. And the height is completely vertical here. It's not diagonal at all. So the height can be a side. But it can also kind of look like the parallelogram one, where the height is going up through the middle of the shape and connecting with the highest point. Or if the highest point is like kind of hanging out from the rest of the triangle, the height can actually be out of the triangle like this one. What you want to look for is a right angle and a dashed line. The height will almost always be a dashed line. So Just some things to remember: the dashed lines show the heights of the triangles, and the red lines make right angles with the base side. So there's right angles in all of them. This one's not in the triangle, but it's still making a right angle with where the base would extend out. All right? So let's do our formula here. Write down your formula, and then we're going to use the base. And here the height is the red dash, so 8, to substitute numbers into our formula. So formula first, area equals 1/2 base height. Remember, again, no signs in between means you're just going to multiply them all together. All right, so we substitute our numbers in, 16 for base, 8 for height. And then in the Desmos calculator, you can actually type in the 1/2 as a fraction first and just keep multiplying. Or you could do 16 times 8 first and then do times 1/2 or divide by 2. Or you could do times 0.5 because 1/2 is 0.5. Or in your head, you could just figure out what half of 16 is first. Half of 16 is 8, and do 8 times 8 to get your answer. Whichever way you choose, the answer is going to be 64. Since it's an area, we're doing square units, so we have square millimeters here. So it's 64 square millimeters, or 64 millimeters squared. So what you'll notice is that the base and the height of the triangle were the same measurements as the base and the height of the parallelogram. And that's going to help us explain why 1/2 is part of the equation. So let's take a look at the triangle here. I have all the work we just did right here for the triangle, and then I'm going to show you all the work we did for the parallelogram. What I want you to notice is that the areas have something that connects them. And what connects them is you can multiply the area of the triangle by 2 to get the area of the parallelogram. So what that means is 2 of these blue triangles should equal 1 of the parallelograms. So I'm going to duplicate this triangle and flip it around a little bit and attach it to the other triangle that we have, and I'm going to show you what it does. Look what it does. It makes an exact mirror image of the pink parallelogram. If I were to flip the blue one kind of like a page of a book, it would be exactly the same as the pink one. So what we just did is we doubled the triangle, and it made the parallelogram. So what that means, or what you want to know about that, is when the heights and the bases are the same for a triangle and a parallelogram, the triangle is half of what the parallelogram is. So that's why we have half here. We take the parallelogram formula, A equals BH, and if we cut it in half, we figure out the area of the triangle that has the same base and height. All right? So hopefully that helped explain a little bit why the 1/2 is in the formula. All right, so practice time. Go ahead and do your practice. Hit pause. I'll show you the work when you're done, and we can talk about it for a minute. All right, there you go. This is what your work should look like. I should not just see random multiplication problems and scribble everywhere and then an answer. You should have neat lines of work for each problem. So for the rectangle, you should write down the formula first, substitute in your numbers, and get your answer with the correct label. Make sure you have an exponent of 2 with your label. Same thing with the triangle. Formula first, substitute numbers in second. So here the base is 7 and the height is 5. And then do your work and write your answer out with the correct label. You could have written 17 and 1/2 here, and that would have been okay also. The Desmos calculator probably shows you a decimal version, I'm guessing. All right, so that was the lesson for today. Rewatch if you need to. Make sure you show your work exactly how it is in this video. Substitute, or formula first, substitute number second, and answer third with your label. Practice this for the homework. Hopefully it won't be too difficult. It's just repetitive, kind of like, you'll get better the more you do. And use this video to help you get ready for your quizzes and tests. All right, I'll see you next time.